So we'll have a review of pointers and structure. So let's say address in C. Think that you have a variable which is having var, name as var in your program. So what exactly this ampersand var will give you is the address in the memory. So we have used address numerous times. So when we are using it in the scanf function, we will be mentioning it as scanf percentage d ampersand var. So var is a variable name. The value entered by the user will be stored in the address of var variable. Let's take a working example. Let's work out and let's see. Let us see in the uh, this. We'll just copy. So in this, what we are going to do in this, since var is equal to 5, and what we will be seeing the use of ampersand in this. So see here, the var value which we have um, initialized and the data type that we have given. Okay, it is 5 and address of var is in the hexadecimal format. Okay. So what does say pointers? Pointers or pointer variables are special variables that are used to store addresses rather than the values. So we have the pointer syntax. Now we will be declaring the pointer as such like this: int star p. So we have declared a pointer p of int type. We can also declare pointers in this way, that is int star p1, int star p2. So we have two pointer variables of the data type integer. Let us take another example of declaring the pointers. You can also declare it in this way, that is int star p1, p2. Here we have declared a pointer p1 and a normal variable p2. So that means that P1 is only the pointer, P2 is a normal variable. Now assigning address to the pointer. Now let's take an example. If you have int star PC and C, C equal to 5 and PC is equal to ampersand C. So what it is? 5 is assigned to the C variable and the address of C is assigned to the PC pointer. Now let us see, we have to get value of the thing pointed by the pointers. So how we have to do that? To get the value of the thing which is pointed by the pointers, we use the operator. For example, we are declared as int star pc comma c. C is equal to 5, pc is equal to ampersand c, print f percentage t star pc. So we have to get the output as 5. So let us understand what these four lines means. Here it means that the address of C is assigned to the PC pointer. To get the here the address of the C is assigned to the PC pointer. To get the value stored in that address, we used star PC. Note in the above example, what we have to keep in mind is PC is a pointer, not star PC. You cannot and should not do something like star PC is equal to ampersand C. You will not get the value which is being pointed. So this is completely wrong. Star PC is equal to ampersand C. This is the right PC is equal to ampersand C. By the way, star is called the dereference operator when working with pointers. It operates on a pointer and gives the value stored in that pointer. Now let us see changing value pointed by pointers. Let's take this example. So we have int star pc comma c is equal to 5, pc is equal to ampersand c, and then c is equal to 1. And c we have to see, we have to print and see how it will be there. Okay. So with respect to this, I will see and type and see how the output is, which is verify whether we are getting the output. So this is what if we are getting the output as 1 1. If you put it as void main int star pc comma c is equal to 5, pc is equal to ampersand c is equal to 1. When the value changes, then it will be printing c and pointer pc as 1 1. So we have assigned the address of C to the PC pointer. Then we have changed the value of C to 1. Since PC and the address of C is the same, the pointer PC give us 1. Let's take another example, which is this. Let us see in the thing. Okay, so the thing is, the value is 1 1. So we have assigned the address of C to the PC pointer. Then we have changed the pointer PC to 1 using pointer PC equal to 1. Since PC and the address of C is same, C will be equal to 1. Let's take another example. Let's see, check with this example. 5n minus 15. So the output that we got was 5 and minus 15. So we'll just understand this code. Initially, the address of C is assigned to PC pointer. Okay, it is declared as pointer. So even if it is int star PC, PC is a PC pointer, and this is the normal integer variable. Okay, so we have assigned by using PC is equal to ampersand C, and C is having the value 5. So star PC will give the value as 5 for this particular thing. Now D is 15. Now D is assigned to PC pointer using PC is equal to ampersand D. Since D value is minus 15, here we are trying to print the pointer PC. It will give the value of D, which is 15. Okay, so let us see the example. We will run the code. So these are the codes which is there. So let us understand the program. So here what we have is int star PCC. So here we have a pointer PC and a normal variable C. Both of type int is created. Since PC and C are not initialized at initially, pointer. Okay, so here A is here a pointer PC and a normal variable C, both of type int is created. Since PC and C are not initialized at initially, pointer PC points to either no address or a random address. And variable C has an address but contains random garbage value. Now, next thing is the next important code that we have to look into is C is equal to 22. This assigns 22 to the variable C. That is 22 is stored in the memory location of variable C. PC is equal to ampersand C in the sense we have to assign the address of the variable C to the pointer PC. C is equal to 11 in the sense we are assigning the value 11 to C, and pointer PC is equal to 2. This changed the value at the memory location pointed by the pointer PC to 2. Now let us see with respect to structure, it is just a review. In C programming, structure is a collection of variables of different types under a single name. How to define structure? Before you create any structure variable, you need to define its data type. To define a struct, the struct keyword is used. And syntax of struct is struct, structure name, data type member 1, data type member 2, and opening flower bracket, closing flower bracket, and there has to be a semicolon. So here is an example of the person. Person is there, care name, int city number, float the salary. So here is a derived type, struct person is defined. Now we can create variables of this type. So creating the structure variable, when a struct type is declared, no storage or memory is allocated. To allocate memory of a given structure type and work with that, we need to create variables. Here's how we create the structure variable. Struct person, name, city number, salary. Name is a character array and city number is integer, salary is float. Now the same thing when we are using it in name, you can use it as struct person, person 1, person 2, P20. That is, you can have 20 names, 20 persons information with respect to name, city number and salary. Another way of creating a struct variable is struct person, character name, that is it's a um, array of character, integer, salary is float, person 1, person 2, and then we have the array. In both cases, two variables, person 1, person 2, and an array variable p having 20 elements of type struct person are created. Access members of a structure. There are two types of operators used for accessing members of a structure. Dot is the member operator, and we have dash. This particular symbol is the structure pointer operator. Suppose we want to access the salary of person 2. Here's how we can do it. That we will be using it like person 2 dot salary. Okay. We'll see a program which we will be using with respect to structure, where we will be adding two distances, that is where we will be using feet and inches, and we'll see how it will be working. So it will be giving like this, that is 25 feet and 6 inches. That is the output. Why structures is used in C? Suppose we want to store information about a person, his or her name, citizenship, number, and salary. You can create different variables, name, city, number, salary, to store this information. What if you need to store the information of more than one person? Now you need to create different variables for each information per person, like name 1, city number 1, salary 1, name 2, city number 2, salary 2, etc. A better approach would be to have a collection of all related information under a single name person structure and use it for every person. So let's see pointers to structure. Here's how we can create pointers to structure, that is struct name, member 1, member 2, closing from bracket, semicolon, int main, struct name, pointer PTR, and the name array. Here PTR is a pointer to structure. Access members using pointer. To access members of the structure using pointers, we use this particular operator, that is dash and greater than operator. So let's see how it will be done. Let us also just work it out and see how the output will be. So let us run and see. So this will be the output. It will be asking for the age and the weight and this. Okay, so this will be the output. So in this example, whatever just we saw, the address of person 1 is stored in the person PTR pointer using person PTR is equal to, which we have used here, using person PTR is equal to ampersand PTR person 1. This one, person PTR is equal to ampersand 1. So what it means that you can access the members of person 1 using the person PTR pointer. By the way, this we have to be known like what it exactly means. Person PTR, this particular operator age is equivalent to pointer person ptr dot age, or else if it is accessing the weight, person ptr weight is equivalent to star person ptr dot weight. So there is dynamic memory allocations of structs. Before we proceed, so sometimes what happens, the number of struct variables that you declare may be inefficient. We need to allocate memory during runtime. Here's how can you achieve in this C programming. Let's see dynamic memory allocation of the struct. So this is the struct we have, and then int main, then person pointer, enter the number of person. Then dynamically we'll be allocating the memory of n members of struct person, and one by one we will be accessing the age. To access the members of first struct person, we will be writing it as ptr name, ptr age. To access members of second struct person, we will be writing it as a ptr plus 1 name and ptr plus 1 age. So for accessing that, we will be using this particular operator. And we have to display the information, and then we will be doing it in this way. So for this, we will be having this particular output. Because when the you can see how the output will be, we will be entering the number of person as 2, and we will be writing the name and the age of the first person, and we will be entering the second person's name and age as gray and 32, and then it will be displaying the information for both the person. In the above example, n number of struct variables are created where n is entered by the user. To allocate the memory for n number of struct person, we used this dynamic, that is we use the ptr pointer to access elements of person. Okay, so hopefully you have understood what exactly goes on in this session.